All right, today we're going to try to get through at least half, if not all, of DNS, and the crowd goes wild. That was almost wild. But what do we know about DNS so far? What is DNS? Who can tell me what it is? Yes?
It's a domain name service that connects IP addresses to human-readable names that we can connect to.
Right. It's like the internet's phone book, right? It's what allows us to not have to remember a whole bunch of IP addresses, and when those IP addresses change, we don't have to remember them. DNS kind of is the easy thing for us to remember in order to get to those resources, okay? So what our goal is in this section is to understand a little bit about DNS addresses, break them down, figure out how to configure them, talk about different zones and how we create a DNS zone, talk about the different types of records that are in DNS. So our host records, our MX records for mail, our CNAME records, which are like aliases, all of those. And then finally, we're going to troubleshoot and see, if DNS is not working, what are some of the things that we can do to kind of test and see. Without knowing a ton about DNS, let's say we have a web server on our local network, and we type in www.whatever the host name is .com, and it doesn't work. What's something that we could try if we try to ping it and it doesn't work by the host name? Try its IP address, right? Because that server could still be up, but that would help us understand if the issue is with the server just being down and like not accepting any traffic, or just the DNS service having issues, okay? So that's one thing that you could easily do, bless you, in order to test that, okay? So let's go through some of the vocabulary. It's important that you understand the vocabulary, especially once you get into the industry. So you understand kind of the verbiage, being able to have a conversation with somebody and not look totally silly, okay? So obviously we talked about DNS being the domain name system. Sometimes it is the domain name service. Our FQDN, okay, our fully qualified domain name, that is all parts of the address that we use when we go to like google.com. The FQDN would be www.google.com. Okay, all three of those parts together are telling us where that server is actually located. Okay, we're looking for the www server in the Google domain, which is under the .com TLD top level domain. Okay, yes?
The hosts file on a computer can
Yep.
override external DNS sources, right?
Correct. So the question that was brought up, the host file on a local machine, can that override? Yes, that's kind of like a instead of going to Google to like find a phone number, it's like the phone numbers that you're saving on your own phone, right? And the phone number might change and out on the regular world, and if you don't update your own hosts file, you'll run into issues. And also on kind of the troubleshooting side, the host file is usually a target for virus infections, because they'll go and change what's on that host file in order to maintain control or re-get control of your machine. So they'll take like google.com as an entry, and they'll have it go to their server in order to download malicious code. So yes, hosts.ini, or the hosts file, is super, super important. Our DNS zones, those are just a way that we can organize different records. They are just like buckets, if you will, of the different parts of the domain that we're utilizing. The thing that you have to remember is the difference between forward and reverse lookup zones, okay? So with a forward lookup zone, we are taking and resolving our fully qualified domain name to an IP address, okay? So what do we think a reverse lookup zone is? Yep. Yes, we're taking IP addresses to domain names. So they go, either which way. So the way I remember this is forward starts with an F, as does FQDN, our fully qualified domain name, okay? So we are starting with our FQDN to IP address. Forward, they both start with an F, okay? Reverse resolves IP addresses to FQDNs. So that comes second. Okay. DNS records, those are just all of our IP addresses, our host names, all the pieces and parts that we need. And then our root server is the anything that is after the dot. So the .com would be our root file server, and then we will kind of work down from there as far as breaking down, finding out where that domain name is, where it was actually managed at. Then we ask that server what the actual IP address is, and then we save that locally. Okay. It's also important to note that our DNS is cached at different levels. So if we are having issues, we might have to flush DNS. Okay. That's one of the common troubleshooting things that you'll have to do. Our TLD, that's our top level domain. That is the last part of our FQDN. So some examples would be .com, .net, .info, .blog, .podcast. There's a bunch of them now. Back in the day, it used to be just assigned to certain countries, is how they were passed out.
Like .tv, isn't that like?
Yeah, it's like some.
No, it's some country on the other side of the world. I'm not even. Are you sure? Pretty sure it might be.
Yeah. So, like I said, there used to be only a few, and now they've kind of opened it up and decided they want to make more money. Another thing we have here, like our host file, we just talked about that. That is a text file that's on our machine that ties host names to IP addresses. We have our authoritative name server. So this is what's going to be where our domain that we purchased, where it's managed through. And then recursive would be other servers along the way that help with the process. Okay. So we can see here at the end of the day, DNS just ties our FQDNs to our IP addresses and back and forth. You'll notice that there are these little dots along the way. Okay. So there's that invisible one that comes after the actual domain. That is the root name server. And then under that, it is our .com, which is our TLD, or our top level domain. From there, we have our domain name that we purchase. So we are purchasing, in this case, TestOut from the .com TLD registrar. So that's what, together, they are testout.com. And then the www is the actual host name of the server. Okay. So there's some underlying technology when it comes to, www.google.com is not living on one server. Okay. It's not just one huge server like the size of, the state of Nebraska. It's spread out amongst several servers all over the world, and there's some underlying proxying that's happening for that to come up. But at the end of the day, normally we would tie one host name to one machine, okay, or one service, okay. So from there, anything that is before that, before the actual test out portion, that is our subdomain. So in this case, sales.testout.com could go to, it could be our email addresses could have that. So for example, at the University of Toledo, our email addresses are first initial last name at rockets.toledo.edu. So that's that subdomain. That's what's been set up for the student email. Yes?
So I understand why you would want all the emails to be uniform so that you can easily figure out who's who and pull them apart. But doesn't that also make it a lot easier for people to guess and check, because now they can figure out almost any email with just an employee list? They may not have the password, but they can figure out the email.
Yeah.
I'm going to guess, what do you have, people who have actual clearance with different emails, different layouts?
No. Yeah, they're usually all uniform, and a lot of that information is public. Like when you're doing your OSINT, you're gathering. That's one of the things that you do is you look at the website and see kind of how their emails are set up, because you might get their first initial last name. Well, chances are that's probably the same as their Active Directory login, and then
you just run a password through all of them.
Yeah. Yep, and just spray it with all different permutations. Yep. So the part before our domain name that we purchased is our subdomain. So in the example here, the sales would be our subdomain. Okay. So when it comes to our actual zones, we can see here the .testout zone has sales.support. And labs. Okay, those are all part of the testout.com DNS zone. This is how we organize it in order to manage it. Okay. So with the zones, there's two different ways that we could do it. We might have the IP address and need the fully qualified domain name, or we have the fully qualified domain name and we need the IP address. Okay. So Our forward lookup zone, what does it do?
Like you look up a host name and it gives you the IP.
Yep, starts FQDN, fully qualified domain name comes first. That is our forward. What does our reverse do? Kegley.
Sends our IP to the host address.
IP to our host name. Yes, that is our reverse lookup zone. Okay. When it comes to zone transfers, so you'll try, like, in the cybersecurity world, if they don't have security set up, we try to do zone transfers in order to take advantage of their DNS and like point their DNS to malicious servers in order to do our attack. But with those transfers, we basically have a main server and then we have our backup. So if something happens, we do have some failover. So that's what our zone transfer would be. So if something comes in, we're able to use those backups. Okay, so you can see there that all of them have the same DNS map for www. It goes to 104.16.127.52. Okay. So what are some of the common, I guess, things that we would utilize our DNS for internally? Well, just host names in general, right? So if we have a standard for like our printers that we know that it's based on their location and their number, then we can easily just remember a lot of that stuff in our head. Or our server names. So let's say we do our servers as, our favorite, our favorite anime characters, let's say. So we then kind of know what those servers do, right? Just by being able to attribute something that's memorable instead of IP addresses, right? So those are ways that we can utilize DNS just to make our life a little bit easier, especially when we're doing things like setting up or like joining to the domain, stuff like that. We can just type that in instead of having to remember all of those IP addresses. Yes?
So do a lot of corporations set up specific domain names for different like file servers so that their employees can just type in, like, say, file server dot something?
Yeah, a lot of times you'll see it abbreviated to like FS1 or FS2. Same thing with web servers, www or www2. So, what's that?
Would it be better just to have one?
It depends. I mean, it really depends on the implementation, right, and what the needs are. If it's a big global company, they probably have localized ones.
You have 10,000 people.
Yeah.
Connect to one server.
In small companies, though, like really small ones, they don't really need big file servers.
And anymore, we're doing so much on the cloud that even having file servers anymore is minimized.
Also, if you plug in an external hard drive, it shows up as a network location.
Yeah, it'll automatically share it out for you as like a home file server.
Really cool.
Yep. And I think it'll do the same for printers too, won't it?
I personally don't know. I know, like, I've seen YouTube videos where some of the newer routers you can just go plug in.
Yeah, plug and play with that USB port. So you can see here just examples, workstation, switch, DHCP server, router. Those are all, it could be an app server, it could be Hyper-V, whatever that might be. And you would save that in our, within our actual zones. Also, I want to point out DNS, okay, that is dynamic DNS. So you may or may not know, and every ISP is different, but most of the time they change your publicly facing IP address, right? Unless you pay for a static IP, it's constantly changing. So if you want to host, say, a web server in your house and you want to access it, well, if your IP address changes, if your internet service provider changes your IP address, that'll break your connections, right? So what you can do is you can utilize a service called DYNE or dynamic DNS. And when that IP address changes, it'll automatically update your record based on that change. So if the ISP does change your IP address, it'll automatically make that update for you so you can still access those servers without having to pay for a static IP.
Would it make it easier if you were to just use IPv6?
Yes.
That doesn't change.
Correct.
So,
Well, I thought the internet providers did that to save on bandwidth. Like, they changed...
Not really bandwidth.
public IP.
Not for bandwidth necessarily. No, I mean they might move it around. Like if they have, let's say, 2 pipes coming in, they might move some traffic, like heavier users, to one. They might try to do something like that, but they could do it for security purposes too. They could do it just so they could sell static IPs. I don't know.
It's just more and more people getting on it.
Yeah.
I didn't know ISPs sold static IPs. I mean, it makes sense because they're servers that just never change their IP
Not all of them do.
Yep. So, with our DNS process, so how do we actually get access to our DNS IP address? Let's say we type in www. owenscoolserver.com. What actually is happening? So, first we're going to look at our host file to see if we have a record for that. We might look in our cache to see if it's there. And then if it's not, we're going to start at the .com. We're going to say, hey, .com, do you know where this domain is hosted? owensawesomeserver.com. So .com is going to say, oh, my record is that I have that listed that it was registered at GoDaddy. You need to go to GoDaddy, to that domain server, and ask them where www is. So then we make another call. Hey, GoDaddy, or wherever the host is, registered and where the DNS server is. We say where www is, and then it'll spit out and say, here is that actual information. Okay? So the .com TLD name server doesn't have every single .com in the world. It just says where where .com is actually managed.
It's like .com is a folder, and inside of everything, like inside of .com, then it goes to other.
It'll say where you go to get the other files.
So
Yep.
it's more like different road signs pointing off in different directions. Like it knows the direction, it just doesn't have it stored on it.
Yeah, it'll just tell you where to go get your answer from.
Doesn't every single one of those hops like .com to GoDaddy increase latency?
Yeah, but it's super fast though. You don't really, because it's cached all over, and you don't really see.
But it does increase latency to a small degree.
A little bit. Yeah.
Just like how if you're DDoS and something increases latency.
So we can see here we are reaching out. We looked at our host file, our DNS server. So in this case, Google.com. Let's say we're using the Google domain servers, 8.8.8.8. It's going to go there, and it's going to see if it's cached first, and then it's going to go out to our root DNS server. So you can see here, it's going to go to .com. Let me pull up my little pen. So the query comes into our DNS server first. Does it have it? No. So then it goes up to .com. .com is going to say, hey, you need to go over to the .com servers. So it goes over to .com, and then it says, hey, where is testout.com registered? So from .com, it's going to say, hey, go over here to say GoDaddy or wherever the name servers are. It'll then finally go to the testout.com DNS server, and it says, hey, www is over at 104.16.127.52, and then that computer has that, and then it'll cache it. This will probably also cache it. That our DNS server will also cache it that first time. Okay, so the propagation, when you first buy a domain name, it used to take a couple days to propagate all around the world. Now it's a couple hours. Even within a couple minutes, you'll start seeing it working. I mean, it's a very fast system now, but it could take 24 hours.
At the very beginning, like when you first launch a website, it will have higher usage at the beginning than afterwards.
What do you mean?
Well, because more things are connecting to it to get it on lists, right?
Basically, from what I understand from what he's saying is that all of the processing is really done on the DNS side to actually get them there.
Yeah.
So your server won't experience any more load. It's just
Yeah, because you're still going, after you get that IP address, that's where you set up a communication between the two of you, just using IP. Yeah, so at that point we updated our Google server. Let's say we're using Google for DNS. So all these other computers that are connected to this DNS server now know. Yeah.
If we didn't watch you draw those arrows, that graph would be extremely confusing.
And that all makes sense.
It's just arrows going everywhere.
I just looked at the arrows and it kind of
Made sense.
Well, it makes sense when
the DNS goes to the .com goes to the, or it goes to the, goes to .com goes to
Test out.
basically just a bunch of
And then it
boolean
all-
values. Are you in here? No?
Yep.
Okay.
Yeah, it's like,
Yeah? Okay, where at?
you see
There?
the one
Yeah?
meme where it's
Okay.
the Grim Reaper and he's going through all the doors and there's a little blood trail leading out past the Grim Reaper and he's going into the next door and they put little logos on it. It's kind of what it is.
So our DNS cache, after we find out an IP address, so you can see here that we made it to the TestOut domain name, so we have our website working. It's going to save it to our cache. Okay, so inside the cache, it's going to have any known mappings, so it's going to keep record of the IP addresses that we found. It'll also have our time to live. So a TTL is how many times it's going to try before it just dies. Okay, we don't just want random, traffic out there filling up the internet pipes, if you will. So it has kind of a self-destruct button. After so long, it'll self-destruct. Yes.
Can you extend the TTL?
Yeah.
I mean, like from a client side, could you like crank that all the way up to the maximum? And
I mean,
DDoS the
potential.
entire internet?
Oh no,
Well,
I mean,
not the entire internet.
you'll have standard, like it'll be a certain number of hops usually. In this case, it'll be DNS so that it just falls out of the cache. So that wouldn't necessarily. So these are the things that we need to kind of memorize for certification. Okay, our A record, that is taking an IP address and tying it directly to a host name. So that is like, for example, www or file server or mail dot anything. Those are going to be our A records. They are going to go specifically to a computer. Okay. The 4A record, because IP version 6 is like 4 times as confusing as IPv4, that is our host name to IPv6 address. Our pointer records are where we're taking an IP address and we're sending it to a host name. So A record is a host name to IP address. Our pointer is an IP address to a host name. Our CNAME, these are aliases. So if we had like awesome website 1, awesome website 2, awesome website 3, and we wanted them all to go to the same website, that would be our CNAME. They're just little aliases, okay, that we can set up in order to access that resource, okay?
Would it send you to the same website?
So I guess an example would be, let's say we have a website and a mail server on the exact same server. We could have it be mail dot and www, right? Because we're going to use www most of the time when we go to a web browser, but if it's also our email server when we're setting up our like our mail exchange records and we're doing like our setup, we would have mail also forwarded to there.
Is that like standard for mail servers, just to have mail dot then like
A lot of times, yeah. But anymore, you're not really seeing localized email. You're seeing either Office 365 or Google as your email providers. Yep. So you're not really going to see any of the Exchange servers out there anymore or any of the open email ones.
I assume the only ones that have it are ones that are like technically off the grid, like power plants, hydroelectric plants.
Even like DoD is even cloud mail. Like even DoD doesn't have email servers anymore.
They're also constantly sending information. So
Yeah. We have our TXT records. That's just if we need to save information in our DNS zone. With that, that's going to be verifying like that you own something. So when you're setting up an email or you're setting up a URL or a domain name in a service, let's say like Square because you want to start accepting payments, or Google because you're going to start doing use their ad service or whatever it is. They need to make sure that you own that domain name. So they'll give you a code that says, hey, add this as a text record in your DNS information, and then it'll query that DNS server as a way to like validate. It's almost like two-factor authentication to make sure that you own something. Okay. Our SOA is just administrative information about the DNS zone, who, what, where, when, how owns it. We have our name server, which is just, again, the whole server as a whole. It says who is going to manage this domain name, or this domain. So if it's testout.com, it's going to say, ns.godaddy.com might be where the actual DNS server lives. Okay, and then the SRV are, if it's non-default ports and stuff, or if there's a specific service that you're going to be used, that's what the SRV would be for. Okay. So we are going to pause here at 5.1, so make sure you get all the way through 5.18. Any questions on the intro to DNS? Remember, at the end of this lab, we are going to build out on our local machines, virtual machines for DHCP, and we're also going to have our DNS server set up. So if you don't have Server 22 downloaded on your local machine, make sure you get it during these times when we break. Okay. Okay, moving on to 5.2 name resolution. So how do we set up our forwarders and how do we create a root zone? Okay, we talked about these already. So we have our forward lookup zone, we have our reverse lookup zones. We remember what those are, right, from 10 minutes ago when we talked about them, hopefully. So we're going to get into what a referral is, iterative, delegation, and all these other important vocabulary words. So starting with referral, so this is the process by which DNS servers use one another to resolve requests from certain clients. So it's like, hey, can you vouch for this person? Or hey, do you know this information? And the other DNS server can be like, yeah, actually I do. Here's that information, okay? We have iterative. So this is where we're actually going to request this specifically from a server, usually one step or one echelon above, okay? We're saying, hey, do you know where this is from? So it is our DNS server's DNS server, okay? Hopefully that makes sense. It's our DNS server's DNS server. So we might have a local DNS server on our network, and then we might be using, that DNS server might be using Google for its DNS server, right? So that is that kind of moving up the echelon, right? So,
Is this gonna fall?
I don't know. It looks like,
Do you need help? Like, I think that this thing might fall. Yeah.
so make sure the wheel is like pulled out towards you.
Yeah. Here.
I think the wheel came unthinged. Grab that PC right there.
Which one?
The thin PC. Yeah. And just put it underneath there. We'll boost it up. Like, lay it down and slide it under there, so the cabinet can rest on it.
Yeah, that's not helping.
Yeah, that's still gonna fall over. Can you pull it back for him? Yes. No, pull it back. Pull it back towards us. Okay, stop.
And now put this in there.
Okay, that stopped it.
I was gonna say that has been. Like,
Here, try to put a hard drive under there instead.
Okay, remove the cords first.
Right.
Try to-
You never had to wedge anything in there before? Like, come on.
No, it's just been leaning bad for a while, but that, like, when I moved that even slightly.
Yeah, no, it felt like it was about.
Okay. We'll pop that in there so I can edit that out. Delegation, this is when we are handing this off, saying, hey, I don't know where to find this. It's now up to you. I'm delegating this task to you, okay? A forwarder is a DNS server on a network that is configured just to send those requests to somewhere else. It receives them and it ships them out of the network, okay, wherever it needs to go. All it does is forward that traffic. And then we have our root hints. So this is a list of DNS servers on the internet that an internal DNS server can use to resolve queries. So it can have maybe 5 or 6 different servers that it can reach out to in order to get that information, okay? So here is our example for our DNS forwarder. A host says, I want to go to Amazon.com. It's going to then send out that request over to a public DNS server, so in this case our internet service provider, and then we're going to look and see where Amazon is, okay? And then it's going to say, hey, either I know where it is and here is that information, I have that cached, or it's going to go through that whole recursion that we saw in the last section, okay? So another thing, we want to make sure that we don't have any man-in-the-middle attacks, right? So what we do is we create this screened subnet, also known as our DMZ, our demilitarized zone, okay? So what this does is it keeps our internal DNS and these queries safe when it goes out to the public DNS server. So it puts kind of a layer in between us and those bad guys. Okay. So with conditional forwarding, why do we want to use it? Number one, it gives us more features. It's not just the standard going, IP address to host name. It's figuring things out and utilizing an algorithm in order to find, the quickest route to get our information. And at the end of the day, it's just more efficient. So you can see here where we are, we have our host. it's going to our local DNS, and then from there, it is going to forward that on to the proper DNS server. Okay, it's going to figure out what is the most efficient path in order to get what we need. So in this case, DC2 or domain controller 2.northsim.com, it's going to hit our southsim or our local DNS, and then it's going to go out to the proper DNS server. Okay. So here we have our conditional forwarding. So we have our Acme Corp and our generic Corp on this side. So we have our internet service provider up here, and then we are sending from Acme Corp. We are forwarding that over to generic Corp, and then generic Corp is forwarding queries over to Acme Corp. So if these two were merged, they're able to now forward that traffic back and forth based on where the, what conditions were met. So if we're looking for something that's over on Acme Corp, it makes sense for us to forward that traffic over to that DNS server in order to get what we need to get. Guys, I'm lecturing, so don't talk over me. Thank you. So with our authoritative DNS servers, that is what is holding kind of the book of truth, right? We are making sure that this is, at the end of the day, this has the list of all of our servers. We don't want this to get broken into. This is what's going to, all of our mail servers are going to be listed in here. All of our host names are all going to be in here. Okay, this is the book of truth. Okay, so with that, we have our authoritative server, and then it's just going to shoot out updates to a non-authoritative DNS server. So at the top layer, at the root domains, those are not opened very often. Okay, we have like one echelon down. Those are our non-authoritative. Those are the ones that are going to get the updates more often, because we don't want to mess with that top level one and introduce security issues. Okay, so here we have our Amazon website, and you'll notice that these IP addresses have changed. So the authoritative is where we are going to say, hey, here is this new address for Amazon.com, and then it's going to push that information to our non-authoritative. All of our traffic is going to be talking to this non-authoritative name server. Okay, that's just adding a layer of security so the bad guys are more likely to target this, and we are not going to have all of our records compromised. Okay, so this is that path where we're having our book of truth, and then we're pushing that to our non-authoritative. Yes?
Now, how would you bypass a non-authoritative server just to get to the authoritative?
I mean, you would have to attack that local, like that actual machine.
So just throw a bunch of thumb drives in a parking lot and like someone plug it in?
Sure. So until that non-authoritative website gets the update, it's going to not find it. But then once it updates, it'll work as needed. So with our forward lookup zone, FQDN to our IP address, and our reverse is the opposite, right? When we have a IP address and it's changing it to a FQDN. So then we get into our stub zones. So with these, you don't really have, if you're going to go for the Microsoft certification, definitely going to have to know some of these, because you're going to have virtual machines that are all working together under one application. So we are building Minecraft, right? Well, we might have 10 servers underneath it that are all working together that are doing load balancing and stuff. So with cloud applications, you are going to have to know some of these things, okay? So in this case, we have our authoritative name server, then we have that firewalled off, and then we have our several different stub zones that are underneath that, okay? So we're going to take a break here until we go to lunch. So this is where you should be caught up to at this point. In DNS, as we study more and more cloud technology, DNS is of the uberest of importance. Okay, so one of the old adages in IT is when stuff isn't working, it's always DNS. Okay, so spending time to understand DNS is super important, And then when it comes to studying cloud technologies and server infrastructure, and we're going to be getting into Active Directory and whatnot, DNS is what makes all of that stuff work together, okay? So as we're moving on, now we're talking about zone management. If you remember, I believe we talked in the last module about forward lookup zones and reverse lookup zones. So if you have an IP address, you could go and get the actual DNS name, or if you have a DNS name, it allows you to go get the IP address, okay? So now we are moving on to the next step, which is where we're starting to talk about Active Directory and its role and how it uses DNS in order to do things like login, when you're logging into a computer, to have all of your users in one place, all of your computers in one place, and apply policies and stuff like that to them, okay? And what is DNS's role in that, okay? So starting off, our DNS zone. A DNS zone is simply just a collection of the different DNS records, DNS or IP records, okay? If we are looking at a forward lookup zone, that means we are going to resolve FQDNs. Who remembers what FQDN stands for? Yes. Fully qualified domain name, yes. So that's going to have the www.google.com is going to tell us what server we're going to, what address, and then what TLD. What is a TLD?
Top-level domain.
Top-level domain. That's going to be like your .com, your .org, your .net, all of those, okay? So your reverse lookup zone is going to be the records that resolve your IP address to those FQDNs. So if you have the IP address, now we need to know what the actual host name is or the domain name is. That's where we would use our reverse lookup zones, okay? At the end of the day, all of these zones are simply just text files, okay, that the DNS service can query and pull down that information, okay? So all of these text files are there in order to tell the computers where to send traffic, okay? From there, what we're talking about here is our Active Directory integrated zone. So that's where we have a specific zone of things like computer names, resource names that are stored in the Active Directory database, okay? Who could tell me in a couple sentences what Active Directory is? What is Active Directory? Yes.
Active Directory is a program used for large-scale computer management.
Large-scale computer and user management. So any enterprise or large instances, I would say probably over 10 people, you're going to want to be using some type of directory service. And with Windows being the most used operating system in the world, especially in business, Active Directory seems to be the go-to for that. So it's important when you're looking for a job in IT that you understand Active Directory. Why do you think it's important to know Active Directory from a cybersecurity point of view? Why do you think?
It helps manage everything, so it's easier to track down what account did what.
Okay, so if you have some type of organization, it'll help you, if something does happen, kind of track that down. How else?
For specific purposes, for explaining things to other people, like and use their ethical hacking skills to say, hey, this is what we need to do. We need to go know what's going on where.
Sure. Okay.
Because if you have a fundamental understanding of stuff like Active Directory, you can make it easier for yourself to find possible vulnerabilities in your system.
Sure. And as an ethical hacker, if that's the path that you're going to take and do penetration testing, targeting Active Directory and understanding how that works is probably a really good skill to have, because now we have all of our usernames, all of our passwords, all of our management. All those eggs are in one basket, right? So if we understand how Active Directory works and we can find different vulnerabilities in Active Directory, then we kind of get the keys to the castle. Yes?
They don't just have their passwords in like plain text, do they?
No, it is. There's like a whole hashing thing with Active Directory, so it's not easy, but it's not hard to target Active Directory.
After you have the hash, you can plug it into hashtag.
Or just pass the hash over. So talking about forward lookup zones, so the different types are FQDN2 IP address. So that's like if you have a name, like someone's name, and you need to find their phone number. That would be your, you use your lookup zone for that specific one would be your forward lookup zone, okay? So you have the name, you need the phone number. Or in the case of computers, you have the DNS name, but you need the IP address so that way you can establish that communication. Remember last year as we studied the OSI model, we talked about that communication, and that's where IP addresses really come into effect, right? So that way the two computers can talk over that over the network in order to move data back and forth. But humans, we like to have easily rememberable things like names and words. Those are, it's easier for us to store that in our brains. So the whole DNS system was used to make humans' lives that much easier. So you can see here just an example. We have labsimapp.testout.com, the DNS client. So in this case, your computer is going to make that request. Okay, I need to go and find out where this goes and what is the actual IP address. So from there, it'll hit the DNS server. If it's already been cached into the first hop DNS server, then it's just going to spit that IP address back out. So in this case, it looks in the forward lookup zone, it looks in the testout.com zone, and then it finds an A record or a host record for the labsim app. So that last part there, labsimapp.testout.com, is the FQDN, or the fully qualified domain name. Okay. Some of your most common record types that you'll run into are your A records. Okay, so that's going to be where we're going to take a FQDN, or that first part of the FQDN, the actual host name, and tie it directly to an IP address. So if we have a Minecraft server that's running at our house, it would probably be Minecraft1 would be the host name, let's say. That's going to tie it to the actual IP address of that server. Okay, and then as you have more and more IP addresses, you can add more and more of those A records. You'll also see a similar thing with IP version 6, but that's the quad A record, because everything in IPv6 is even more confusing, so that's 4 times as confusing, I guess. But you have the 4A record. That's going to take a name and tie it to an IP version 6 address. Next, we have our CNAMEs. CNAMEs are kind of like aliases. So if I want Minecraft1, Minecraft, my Minecraft server, all of those to go to that device, I can put in multiple kind of aliases in there. And then we have our pointer records. So these are just going to point certain names to certain paths. Yes?
Does that mean that, I'm sorry, can you go back? Does that mean that CNAME also goes through A? Like, because it's just giving you a host name and then that's going?
Yeah, a lot of times your CNAME, the actual part in the record, will just point to A. Yep. So that way, if A ever changes, all your CNAMEs will continue to work. Good question. So with our reverse lookup zones, that's where we're going to take our IP address to the domain name. So in this case, we have, let's say 194.28.32.1. We have that IP address, but we don't know where it goes or what the actual domain name is, and it's able to look that up. Okay. So most of the time, we're going the other way, where we have a domain name and we are going to an IP address, but the systems will work back and forth and update those things, so that way the computers have the information that they need and the humans need the information that they need. So we can see here there is an example of a spam email going out, and it's doing a reverse lookup zone. It's going to look into the reverse lookup zone to see where that's actually coming from. And if that MX record doesn't match up, it kind of knows that it's going to be spam in that case, right? It's knowing that it's not coming from who it's supposed to. So here we can type in this IP address and do a search on it or a query for 52.40.152.46. And when we get the reply back, we're going to notice that it is, in this case, not testout.com. Okay, it's some other URL. It's some other domain name, so that's how we know that it is not a it is not coming from who it says that it's coming from. So when we're actually doing DNS, when we're actually doing queries and things like that, it's important to note that this is not just one DNS server that holds all of this information. Why do you think that is? Why do you think this is a distributed system? Yes?
If one goes down, you have a backup.
Exactly. If one goes down, you have a backup. That's certainly important. And then also, think about the millions of people and millions of computers in the world that would be trying to hit one server at a time, right? There's just not enough bandwidth. It doesn't make sense. So that's why there are multiple servers that are set up in order to relay this information. Yes?
Wouldn't that be like also good for a security thing? Because everything would be a lot more isolated.
Yep. And a lot of times your highest level of domain name servers are not going to be internet connected. They are basically unlocked. They do updates and then they close them back up to keep like a master file, if you will, in case something does happen. Yes?
That's how like power plants and stuff operate, right? Because they don't want to be accessible to the outside world.
Correct. Yep. So when it comes to kind of your standard versus your Active Directory integrated zones, most of like the regular internet are going to be just our standard name server, our standard DNS zones, where inside our organization, that's where we're going to see our Active Directory zones, okay? So most of the time for like if you set up a website or you're setting up your own custom email, like I have tjhouston.com as my email, that is set up with just standard zones. It's not integrated with Active Directory in any way. Like I don't have the tjhouston.com domain where I have to authenticate against, right? And just using the I'm just using the standard zone for that. So I think we might have talked about this before, doing zone transfers. So if something happens, again, wanting to provide the most amount of redundancy as possible, that's where zone transfers come in, where we can move the records to another server. We could have multiple servers that are kind of communicating, and that also helps with our load balancing, right? If we have thousands of people trying to go to one DNS server, we're going to have problems, right? So that's where we want to make sure that we have the most amount of redundancy and load balancing as possible. Yes?
So when you say move, it really just copies the information, right?
Yep. With the zone transfers, there's a couple things that'll cause them to automatically do it. Number one, they just have a refresh interval where they go and say, hey, it's been a while since I've gotten an update. I'm going to go see if there's anything new out there. And then there's also a notify function. So you can force a zone transfer to happen as well. So you can see here, zone transfer, and then it's serialized. Just a way to keep track of like what version. If you've ever looked at any projects on GitHub, you'll notice that those updates have hashes that are tied to them, so that way you can undo to a certain point. It's kind of that same thing, right? So you can see here it hits the it hits that refresh interval, so it has copy 61833. We can look over here on the left-hand side and see that that's now going to pull a copy of it. And if you look on the right, it has not got that newest version, right? It is still on 61832. So then it'll go ahead and say, hey, this is different. It does notify, and then it'll go ahead and do that zone transfer to keep everybody in lockstep, okay? It is worth noting from a cybersecurity perspective that there can be some tampering that happens here, so you want to make sure that you are using some of the built-in security features with DNS, which we're going to talk about, to make sure that the bad guys don't, basically inject bad records and then force everybody to get those bad records, okay? If we have google.com going to our bad page that then poisons their traffic, then our users are not going to be happy, right? They're going to be unsecure, and we have a huge problem on our hands. So we want to make sure that we are, securing it to either make it so they only transfer to certain servers, or other security protocols are put in place that we're about to talk about. Yes?
So if you're able to poison it to force it to redirect to somewhere else, how big of a problem would that be? Like, does it depend on where you're able to poison it? Like, if you were
Yeah.
able to poison one of the root DNS servers, like the dot server, let's say,
Yeah.
would that?
Oh yeah, I mean that'd mess up all the things. So that's why there's so many levels of installation, so that doesn't happen. And to my knowledge, I don't know that there's been any huge DNS attacks in the last 15, 20 years.
Like, so there's like a master list on your computer that lists all the root servers, right? All the
Some.
DNS servers.
It depends what it's learned about, right? So if it's a brand new computer out of the box that hasn't even done any updates or anything, and it's just connected to the internet for the first time, it's not going to have a ton of those servers. It's not till it actually starts doing querying and NS lookups and stuff like that.
The more you use your computer, the longer that list will take.
Correct. Yep. So ADI zones, again, the big thing that we're looking here is inside our organization and tied to Active Directory, and what it achieves is storage of those records, obviously, replication. So if there's, let's say we have offices in 5 different states, they probably have replication happening to make sure everybody gets those records, and then security to make sure that that information stays secure, so we don't have man-in-the-middle type attacks. Okay, so we can see here, in this last one where the attacker was there, it was not encrypted, so that traffic was going across, so they could potentially poison that traffic that way. When we have our Active Directory, those zone replications where they're passing off that information is all encrypted. Okay, so they all trust each other. Everything runs on Microsoft. Note on the diagram it says no Linux. Active Directory is very much a Windows thing, and those replications that happen are all in sync, and everything is encrypted. So you can see here, when we're doing our replication scope, we can say we want to send our updates to all domain controllers in this domain. So making sure that everybody that's out there, across those 5 offices can get access to them. Okay. Dyne DNS or dynamic DNS is something that in my career I used it for hosting things at home, because if your internet service provider decides to change your IP address, then that's going to break your DNS records, right? Because you went in there and you tied an IP address to a domain name. So with Dyne DNS, it'll communicate with that change and update that. But on a more localized front, more like an enterprise setup, it's going to actually talk to the DHCP server. So when a new computer gets a new IP address, it's automatically updated. That DNS entry is updated. Do you have a question?
Okay, so how would you get a dynamic DNS server? Well, how would you get it to be dynamic in, say, a host file? Right? Like, could you have that automatically update?
No. So the way it works is with Dyne DNS, at least back in the day, you'd have an application that's running on your local computer, and then whenever it sees a new public IP that it's using, then it would update your DNS record, very quickly. So there would be very little to no downtime of that happening. Yep. Okay, so troubleshooting DNS. Like I mentioned at the top of this presentation, there was an old adage of it's always DNS, especially when it's looking at Active Directory and different logins and stuff like that. So one of the tools that we can use is NS lookup. Okay, so with NS lookup, so our name server lookup, we can directly query the DNS address or the DNS server that we are connected to. We can also use tools like ping in order to ping certain domain names. We could do tracert or traceroute, which will show us the hops that our traffic is making. And we can also use the dig command, okay, to dig in to see what IP addresses are resolving to what names and vice versa. Okay. Most of the time with Dig, you're probably going to be on a Linux machine, whereas NSLookup is going to be on the Windows side. Okay. So what we can do if we want to first do a ping, let's say we try to go to a website and it's not working. Okay. Well, what we can do is we could just find out what the IP address is, either on another device or by if we have record of, like, we know that 8.8.8.8 is Google. Okay. So we could type that in. So that's going to first tell us that, okay, we're at least getting traffic out of our network. Okay, so you can see here that is a public IP address 74.125.195.139. So we know that traffic is at least getting out of it is at least getting out of the network. Yes.
Could you also tell to see if traffic was getting out by pinging, say, just typing in www.google.com, because it should resolve to the IP address, right?
Yeah, so the first step is doing the IP address, so that way traffic gets out, and then you can actually ping www.google.com, and then it'll query DNS to get an IP address in order to, get your reply back. Okay. So some of the common DNS issues that you see are, obviously with DNS being down, that's a big one. Firewalls blocking your pings, so that could give you kind of a false. Yeah, exactly. So you got to double check that. It could be, just routing. It could be that traffic is going one way when it needs to go the other. And what I mean by that is, I was actually troubleshooting this on Thursday. Over at ACCA, we had cut over to a new internet service provider, and I was able to ping google.com, and I was able to ping the IP address, but when I went there with a web browser, it wasn't working. And turns out, we weren't able to, it was the filter that was actually the problem. So not the firewall, but the actual filter, because we were using certain DNS servers. So again, DNS is almost always the issue. Okay, so understanding it is super important. Another thing we could do is, using Dig or NSLookup, we can actually see what IP address the computer is getting for a certain domain name. Okay, so by typing in NSLookup and then an IP address, or NSLookup and telling it what name server to use, you can see what exactly what IP address is coming through, and make sure that that is the proper IP address that it is supposed to be. Okay. Some of the other issues is the if your traffic can't get to the root level DNS. So if there's a issue kind of downstream, or maybe it hasn't propagated, right? So if you just bought, adrianisawesome.com, then that's going to take a while for that to get across the world. We all know that already, right? But the actual domain propagation might take a minute, especially on those kind of root level servers. Yes.
How long would you say it would take, like, on average?
It used to take like a week. Now it's down to a couple hours, and sometimes even minutes. And again, it also depends on which TLD you are working with, right? So if it's a .com compared to some of the smaller ones, that could exactly.
Probably going to take longer than a .com.
Correct. Yep. So you can see here, you can test both your authoritative and non-authoritative. So what that means is kind of your primary one that is set to use, and then you can also try just bouncing it off of like Cloudflare, which is 1.1.1.1, Google's, which is 8.8.8, Amazon. So you can bounce that off of those. Cloudflare, I know.
That seems like a steal.
Exactly. They probably spent a lot of money.
Oh yeah, that's
So.
like those license plates in Dubai. Like, the lower the number, the
More expensive. Yep.
You want to know the U.S. Department of
All right, picking on where we left off, DNS protection. Like I said, we want to make sure the bad guys do not inject any
bad DNS, and making sure that, when we're transferring that information between servers, that it stays, that it does stay protection. So let's talk about some of those cybersecurity tools that are built in for DNS protection. The biggest one being DNSSEC. Okay, so these are security extensions that have been created in order to make sure that only the people that get the information or need access to the information are the ones that interact with it. Okay, so DNSSEC or DNS security extensions protects the DNS client by verifying that a server's response was not changed in transit and that server sending the response is who it claims to be. So when we think about our CIA triad, what are those two things that are being maintained there? 2 out of the 3 parts of the CIA triad are fixed or verified with DNSSEC. What are they? There's only 3 options, and we're looking for 2 out of the 3. Yeah. Yep. So integrity and anybody? Bueller? Confidentiality. The CIA triad. Okay, confidentiality and integrity. Also, we are maintaining availability kind of too, because if we are doing those 2 things, we're making sure that it does stay available for the users that needs it. Okay. Another thing that is used is DNS socket pooling. So we're basically going to take a bunch of ports and only use those ports to get the DNS information. Okay. Finally, DNS cache locking. That's going to make it so once the information gets put onto that server or that update comes through, then it is locked so it cannot be changed. Okay? So with our DNS protection, we have our on-path attack and DNS spoofing. Okay? So with this, our bad guy can sit in the middle and say, hey, I'm your DNS server, and then send you to a fake website. So if you're going to your bank, if they are able to inject themselves and say that they are your DNS server and that they are the single source of truth, then they can redirect that traffic to go to a bad website and do credential grabbing. Okay? So with DNSSEC, because we are using some of those security extensions, we make sure that if you notice there's a key here with the DNS server, so that way if there is a man in the middle, when that comes through, the client, the computer, is going to know that it did not come from who it said it was going to come from. Okay, the keys do not match, so that's going to be cause for an alarm, and it's going to not take that update from that DNS server. So another thing is DNS cache poisoning. So with that, we can write, if we were to go on all of the computers that are in front of us and go and go into the hosts file and redirect google.com to the school's website, we are in fact poisoning that cache. We are modifying that hosts file. Okay? Or if we directly wrote to the cache on the computer and said, anytime you go to google.com, I want you to go to acwhcc.org. That is poisoning that cache. Okay? Again, users are used to just typing in names and then just going to websites. So if we can mess with the DNS, we can have them go to our website, which is the bad website. Okay? So it's going to look at that cache, it's going to go to the bad website, and we'll be able to do some credential grabbing or potentially, inject malware onto their computer. Okay? So another thing is the socket pooling. So most of the time, port 53 is where all of the DNS traffic happens. But if we're using socket pooling, the attacker is not going to know because there's 2,500 different ports that could be used. Okay, so this is kind of a security through obscurity thing because the attacker is not going to know what ports are being used for those updates. Okay. So with DNS cache locking, we have our temporary record. And we also have our TTL. So TTL is time to live, and once that ticker goes up so high, then it'll automatically self-destruct, okay? So again, that's less time that information's out there for attackers to see. Another thing that we can do is do response rate limiting. So if we're seeing a ton of traffic coming in to either to our DNS server or from a certain place that looks kind of out of the ordinary, then we can turn on the response rate limiting, okay? So that way, we're able to monitor those transactions that are taking place, so that way we do not fall victim to our attacker. So you can see here on the DNS client, send me all the DNS records. But if we are doing response rate limiting, we're not going to allow them to see all of the different records. And now remember, it could be a computer system with 15,000 computers. So it'd be kind of weird for a client just to say, hey, could I see all 15,000 of those records, please? Like, that's just not normal use case, right? So that's where having that response rate limiting can help us to mitigate our attacker's ability to take over our DNS or attack us using our DNS as our attack surface. Then we have our DANE. So this is again using a fingerprint, or in this case it would be some type of security key in order to make sure that that person is who they say they are. And so in this case you can see the fingerprints do not match because of using the DNS security extensions. So it is going to not allow that update to happen, okay? So in the lab, you guys will have to do or set up some of those DNS security extensions. Okay, next section, our hybrid domain name resolution. So what we're really studying in this module is, yes, how to set up, servers on our local LAN, but then also how can we use the cloud in order to, give us more redundancy, load balancing, scalability. Okay, all the great things that the cloud has to offer. So in this case, we're going to talk about Azure DNS, Azure Private Zones, and ExpressRoute. Okay, so with Azure DNS, we basically have another zone that's up in the cloud that allows you to, yes, have a backup, but also have a place for your cloud infrastructure to also resolve to, okay? We also have our Azure Private Zone. So this is going to only be used for, it's kind of like an internal DNS server, like I talked about with Active Directory, integrated domain zones on our local LAN. This is a similar thing, but up in Azure. And then we have our ExpressRoute, which is a private connection to make sure that our stuff stays safe and it doesn't go out on the public internet. Okay, it's an encrypted tunnel that no bad guys are able to do any of those cool man-in-the-middle attacks that we talked about. One of the common terms that you'll hear when you're looking at different solutions is on-prem. On-prem means on-premises. Okay, so on-premises, we are going to be using the Windows operating system, but when it is cloud-based, that is going to be the Azure OS. Okay, so when we're doing hybrid resolution, you can see here we have a machine that is connecting to our Azure DNS private zone. So over here we have our virtual network, which is 3 or 4 servers over there, and we have an outbound endpoint and an inbound endpoint. Okay, so as these connections come in, it's not going to go directly to the Azure DNS zone. Okay, just like the DNS server, our local on-prem isn't going to connect. What's going to happen is their outbound endpoint is going to forward that information to the DNS server that's on the on-premise network. Okay, so because of that ExpressRoute, because of that secured tunnel that we've made here, the attacker that you see here has no idea what's going on inside of that tunnel. Okay, and it's important to note that that could be ExpressRoute, which is Microsoft's own version, or it could be a VPN tunnel in order for that to happen. Okay, so what that does is it connects the cloud and your cloud infrastructure to your local or your on-prem network infrastructure, and it allows them to stay in sync in a secure manner. Okay, because at this DMARC is where it is the most susceptible for attackers to start getting access to information. As soon as it leaves your private network, it leaves your DMZ, it's out on the public internet. That's when the bad guys can start looking at it to form their attack. So by having a VPN or using ExpressRoute, we're able to have the best of both worlds, and we're able to use the cloud as far as our cloud infrastructure and our local infrastructure like the Azure integrated DNS zones with our local stuff, and that ExpressRoute of that VPN keeps all of that in sync. Okay? Any questions on DNS as a whole? I know that was a ton of information. I think as we set up our Active Directory servers, which is what we're going to be doing on, what is today, Monday? On Wednesday, the plan is to fire up VirtualBox and set up your own Active Directory server, set up a Windows client, and have them authenticate. Okay? I want to start getting you guys acclimated to some of these things so that way you could start putting them on your resume. Okay? Any questions, preguntas, anything?